Welcome and thank you for tuning in. Today we're going to go ahead and continue working on congruences. So this is going to be day number 2. So thank you for tuning in and let's just go ahead and get started. So the first thing we're going to do is go over some background knowledge. The first one is orientation. So what is orientation? Basically, it's the angular position of something. Okay, so a good example I could think of is your phone. You all know your phone. This right here is often referred to the portrait orientation. And then when you flip it sideways, it rotates, and this is often referred to as the landscape orientation. So when you're thinking of orientation, again, just think of its angular positioning. That's it. The second background knowledge we're going to go over is shapes. So most of you know what shapes are. It's basically the form of an object. Some common shapes would be circles, squares, and triangles. The third thing we're going to go over is size. What is size? Size basically describes how big something is or how small something is. That's it. Okay, so now we're going to be reviewing over some transformations. The first one is translation. What is it? Basically, it is a sliding with a figure without it turning. So let me give you a quick visual. So here I have an arrow. I'm going to slide it all over the place. Notice it does not turn. This right here is called a translation. So now if you take a look here at our table, let's talk about what it keeps. What does it preserve? When I translate a figure, what happens? Does it preserve size? I think so, because they seem to be the exact same size. Even if I put it right on top of each other, you'll notice it looks like there's only one because they're exactly the same size. So I'm going to go ahead and put a check mark there. Well, is it the same shape? Yes, again, they're both arrows. What else? Is it the same orientation? Well, yes, again, orientation is angular positioning. It's still pointing to the left. So I'm going to say yes, it does preserve orientation. Another transformation we've gone over is reflection. And yes, it was super corny, but I'm pretty sure I made you laugh. What is reflection? Basically, it flips a figure across a line. So again, to give you a quick visual, this arrow right here, if I reflected it, okay, it could look something like this. So now it went from pointing to the left to pointing to the right. That can be referred to as a reflection. So now again, let's take a look at our table. What does this preserve? What does reflections preserve? Does it preserve size? Do they look like they're the same size? My answer is yes. So I'm going to go ahead and put a check mark there. Let's see. Is it the same shape? Again, they're both arrows, so yes, they're the same shape. Now, is it the same orientation? No. Why? Because one is pointing to the right and the other one's pointing to the left. So no, it's not the same orientation, even though they both appear to be in landscape mode. They are not in the same orientation. Okay? So moving into the next transformation, which is rotation. What is a rotation exactly? Well, it moves a figure across a fixed point, kind of like a clock. Okay, so let me give you a quick rotation of this arrow right here. What if I rotated it 90 degrees clockwise? Then you have something that looks like that. Okay, well, what if I rotate it 270 degrees clockwise? Now it's pointing up. Okay, what's the other one that we've learned? Oh, what about 180 degrees? Now notice our arrows are pointing in all different directions. It was originally pointing to the left, now it's pointing up and down and to the right. So it's kind of all over the place. So let's discuss again what happened. Well, did it retain the same size? Check. Did it retain the same shape? Yeah, again, they're still all arrows. Okay, and next, did it retain the same orientation? No, because they are pointing in all different directions. So no, it does not preserve orientation. Now going over some stuff that we kind of went over today, which in this case would be congruent figures. What are congruent figures? Basically, they are shapes or figures that have the same size and the same shape. So what I mean by this is if I have this check mark for size and for shape, that means the shapes are congruent. Okay, they just need to be the same size and same shape. Another thing we went over today was corresponding sides. Most of you were able to figure it out. However, you weren't using the words I was hoping you would be using. So I'm going to encourage you for tomorrow to start using our vocabulary words. So basically they are matching line segments. So here I can say something along the lines of, let's see, segment AB is congruent to segment, well, AB would be YE. Segment BC is congruent to segment ES. So I'm going to say segment BC is congruent to segment ES. And last but not least, I would have to do first and last. So I'm going to say segment AC is congruent to segment YS. Sorry for my very sloppy handwriting, but you get the idea. They are matching. Okay, so that's what corresponding sides are. So from now on, what I want to hear you say is segment AB and segment YE, not AB, not just YE. Got that? Now we're going to go over corresponding angles. So what are corresponding angles exactly? Basically, they're matching angles. So here, I'm going to say that A corresponds to Y, so I could put angle A is congruent to angle Y. Here, B corresponds to E, so I can say angle E is congruent to angle B. So notice I purposely put them reversed. Does it mean it's wrong? No, it means the same exact thing. So the next one is C corresponds to S, so I can say angle C is congruent to angle S. In class, I want you to practice saying angle A is congruent to angle Y. Don't just say A is congruent to Y. That is not good enough for me, okay? Okay, so now we're finally actually going over our first example for today's lesson. It says here, for number 1, describe one transformation or sequence of transformations that will carry quad TAPR onto quad LH and W. Well, taking a look here, it seems as though it looks like a rotation. In fact, it looks like a 180-degree rotation. So I'm going to write that down. It looks like a 180-degree rotation. Whoops, 180-degree rotation. Let's see, which direction is it going? Well, it seems like it's rotating this way. So I'm going to call it a clockwise rotation. But there's another one. There's another way I can get the same type of figure. To me, it seems like it's reflecting off of this x-axis. So it got reflected, but then after you get it here, it would have to reflect over the y-axis to end up here. So I can say it could also be a reflection. Oops, reflection over the, let's see what we said, y-axis first. Then reflect over the, I promise I'm better at typing than this, the x-axis. So those are my 2 possibilities. That's it. We're moving on to number 2. So here, I don't have the instructions posted, but I will tell you verbally what the instructions are. The first instruction is to figure out how did that shape translate to the other shape. Here, to me, it seems like it's a reflection. Okay, so I would say that it reflected right through the middle. So here, I'm going to say it's 1, 2, 3, 4, 5, 6, 7, 8. So in between would be 4, 1, 2, 3, 4. So basically, it was reflected off of this line. Okay, so it is a vertical line cutting through the x-axis at -2. So basically, it was a reflection across, let's see, x equals -2. Okay, so I got that. The next thing is, well, let's talk about reflections for a second. We talked about it earlier. Reflection preserves shape and size. So guess what? These 2 shapes here are congruent. So let's write a couple statements. Ln, right here, so Ln is going to correspond to EF. Okay, so I'm going to write that down. E, F. Got that. Let's see. MN. MN is going to correspond to DF. So I'll write that down. Segment DF. So I want to hear you say segment. Let's see. Angle E corresponds to, well, let's see. Angle E is going to then correspond to angle L. Okay, and last but not least, angle F right here is going to correspond to, well, of course, angle N. Look how easy that was. Okay, so now for example number 3, we are asked to do 2 things. Number 1, write a congruent statement, and then 2, list all congruent corresponding parts. So we're going to do this real quick. It says write a congruent statement. So here, I'm just going to go ahead and pick a random point to start at. So I'm going to say X, Y, Z. Got it. X, Y, Z is congruent to, well, let's see, I chose the longest side, and then it was the short side, and then it was the medium, because I went in that order. So I need to find the same order here. Longest side, shortest side, medium side. So it's going to be PRQ. So triangle PRQ. Voila. Now I'm supposed to list all corresponding parts. So that means all congruent angles and all congruent sides. So here, I'm going to go ahead and list it up here because I have more space. I'm going to say angle X is congruent to angle P because it corresponds to P. Angle Y is congruent to angle R because it corresponds to R. Angle Z is congruent to angle Q, again, because they correspond to each other. Now I got to list all the line segments. Again, use the word line segments. I'm going to say line segment XY is congruent to the first and second line segment PR. Now moving on to the second and third, so line segment YZ is congruent to line segment second and third RQ. Now I'm running out of shifts, so I'm going to go ahead and do first and last. So I'm going to say line segment XZ is congruent to line segment PQ. Done. So now for number 4, here they give us a pre-image and an image. So basically it says here that it is a translation. I can clearly see that it translated upwards. It's asking me, is the resulting image congruent to triangle ABC? Why or why not? Duh. They are congruent. Okay, they are congruent because, let's see, it was a translation, and I know that translations preserves, fancy word there, preserves size and shape. Henceforth, they are congruent. Remember, congruent means they have the same size and the same shape. Moving on to number 5. So here, they're asking us, okay, based on the image we're given, is the figures congruent? It looks like it's a reflection. So I'm going to say they're congruent because, again, what do we know about reflections? It preserves the same shape and the same size. So I'm going to write that down. Yes, they are congruent because it is a reflection, and reflections preserves, that fancy word again, shape and size. That's it. Okay, moving on to number 6. Same thing. We're given an image and we're asked, are they congruent? By the looks of it, I'm going to say no. Okay, this is actually a dilation. When we enlarge it, we make it either bigger or smaller. In this case, it's obviously bigger. So I'm going to say no, they are not congruent because they are not the same size. Done. Now for a quick recap, it says which of the following properties of a figure can change during a rigid motion? Real quick, what is rigid motion? It is translation, reflection, and rotation. So will orientation ever change? The answer is yes, it will. When? With rotation. So yes. Now I'm going to say when it comes to rotations. Okay, I'm just going to put that real quick You obviously hear what I'm saying. Okay, well, what about side lengths? The answer is, will they ever change? No. All of the different transformations we've learned that are rigid motions always preserves size. So we're going to put no, it preserves size. Okay, let's see. And what about interior angles? That's a very good question. In fact, I'm going to save it for you for tomorrow. So, thank you for tuning in, and until next time, keep doing your homework. So moving on to our next So moving on to the next